Well, good morning. My name is Arthur. This is Frank. We are going to talk about malicious HID devices. We will present what is HID devices just after. So we're working for a CERT bank, a French bank. The agenda for today, we will start with a short introduction about HID device and specifically the presentation of 3 malicious devices. We will spend some time on attacker possibilities. So Frank is doing blue team, so defense side. I'm on the red team, so the attacker side. And Frank will do some practical hardware forensic on the malicious HID devices and what information can be extracted from a chip. And finally, some takeaway.
So, first things first. What is an HID device? So HID stands for Human Interface Devices, and basically it's a device that takes input from a user, and you know them as a keyboard or mouse. This device can be subverted to be malicious. If you remember, 6 years ago, the NSR Toolbox leaked in press. And one of the implants is the Cottonmouth. Cottonmouth is an HID implant which embed the 2 modules, the Trinity, the multi-chip module, with an ARM9 flash memory and FPGA. And the second module, the Howler Monkey, which is and radio frequencies module, allowing to remote control this device. 10 years ago, this kind of modules cost about 20,000 dollars for one, and since 4 cheaper implants have been designed, and now they were available for anybody.
So. I think most of you have heard of Ducky, probably the most well-known HID devices and one of the first available on the internet. It's pretty simple. You plug what seems like to be a USB key and it simulates a keyboard, so it executes a payload. The payload is stored on a SD card, so it's a compiled binary on the SD card, FAT32, and that's all. That's pretty simple. Just simulate the keyboard and launch the payload. There is far more interesting devices, and this one, the weight injector, is really interesting because the W stands for Wi-Fi, and for the rubber ducky, you have only the USB connection. For this one, you have the USB connection, but you have also Wi-Fi. Wi-Fi as access point or as a client. So it means you can connect on the board, or you can tell the board to connect on an open Wi-Fi, for example. It has many interesting features, such as a serial port, which can be used to exfiltrate data, so it's interesting. And it's pretty easy to hide the chips. You have some soldering skills. For example, we have weaponized this mouse, so basically the chip is inside the mouse, so the mouse is fully functional, but it can also simulate a keyboard and launch some payload. So it's a really, really interesting device. So we created this one for demonstration purpose at the bank. And the last one is a USB Ninja. It's the most recent, I think. The interesting feature is that you can start the payload remotely thanks to by Bluetooth Low Energy. So that's an interesting feature. So you can be away from your target. You just click on your phone and the payload is executed. The most complicated part is that if you want to store payload on the cable, it looks like a cable fully functional cable. You have to recompile an Arduino program and upload it on the board. So it's a little expensive for what is it, but the form factor is very interesting. So the attacker's perspective with this kind of device, maybe some of you have seen Mr. Robot. During the season 1, they want to infiltrate, I think it's a prison, a jail. And Marlin drops many USB key on parking. And the USB key or HID devices, which start to payload to gain remote access. So you have many ways to do it. The most simple way, and probably the most used by malware, actually, is to start PowerShell. So you just type Windows R, open the execute prompt, and you tap this line, and you have remote access to the computer. So the user will see it, but if it's done quickly enough, it will be almost invisible. So it's really interesting. That's one opportunity. I think most EDR products will catch this line. But you can do something else, such as use lolbeans, so execute legitimate Windows binary to download a program, by example, certutils or bitsadmin, or you can drop embedded files in the payload, execute it, set persistence. You can do what you want. Another option, I talk about it with the Red Cactus, is that you have a serial port. So on Windows 10, serial ports are automatically linked to a COM port, so you can talk with a COM port in PowerShell. So it's pretty simple. You write a simple payload. You read on a code the file you want to exfiltrate in base64. And yeah, dirty payload, but you can iterate through all available COM ports and try to write the base64 chunk on all ports. There will be the good one, and normally you will be able to exfiltrate data. But you still need to get access to the weaponized object to get the file back. So if you are in the Wi-Fi range, it's okay. You can just exfiltrate via Wi-Fi. Maybe you will need to get the device back. It really depends on the context. So I will let Frank talk about some forensics of what we have done with the mouse.
Now, on the blue team side, how handle an incident related with a malicious HID device. All start with an alert. Somehow an alert is raised. Maybe it's your DLP system, or your event management tool, or a user that reach you because he spot a suspicious behavior on his computers. So you directly start your basic forensics layers. So you collect the targeted devices, you dump the data, you make your timeline, you run your tools, your lovely tools. You extract indicator of compromise, and you give them to your threat hunting team, and you hunt on the networks to see if there is other related device in this attack. And you repeat the process, basic. Okay, now, as you may know, Windows is full of useful artifacts. For our perspective, when we analyze this kind of incidents, we always pass through a USB user review. And in our case, we spot that at 46 and USB device is connected, and at the exact same time, you can see at the exact same time you can see that there is other HID device connected. So we have the mouse here, and at the same time, we can see you have serial devices with another VID, PID in notification, and a USB hub, and this must raise an alert during your process. And by the way, if you want to know all about the ImCache Hive, you definitely want to read the paper written by Blanche. She's here today. So when we review our timeline, we see within that USB devices were connected, and when we review the Windows event log, two specific Windows event log were really useful for us. So the first one is the event ID 225, which means that your USB device cannot be removed because it's currently used by the listed process, in our case PowerShell, and make a link to the specific device that can be not removed. And in our case, remember, slide just above, the suspicious VID PID. So you definitely want to review if any event ID related to PowerShell is present. And reviewing the event log 600, it shows a command line run on the computers with an encoded payload. It's base 64 encoding, so it's quite easy to decode. And when you decode it, you can see what the attackers want to target. So in our case, we learned the attackers try to exfiltrate the content of a specific file through serial port. So at this moment, we know that USB key, USB device was used to launch a potential payload to exfiltrate data. Okay, so we don't panic, of course. We assume we can retrieve the USB device. And now what to do for the analysis of this device. The basic rule, okay? The basic rule, do not connect a USB device untrusted on your computer. I know it's a kind of classic rule, but it can happen even to the best of the best. And I can hear some of you in the room saying, yeah, blah, 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 I have a Mac or Linux, I'm secure, booyah, okay. But what if you may be able to connect the USB killer? Okay, this lovely USB device will discharge about 200 volts through USB on your device, and this could be fatal for your lovely computer. Or you may be able to connect a USB device like the proof of concept, Mr. Self-Destruct from Groover, that activates 5-volt payloads and, in the best case, release some gases or explode. So the basic process in such case, you have to do some external and internal inspection to determine if there is a storage available for this to analyze this. If you have X-ray, perfect. But at some time we have to tear down the device, okay? And if there is data to dump and to analyze, you have a great chance to have to open the device. The simple case, rubber Ducky, okay, you open the frame, you extract the SD card, you dump the data, you use the favorite tools to analyze it. There is also a tool already available.
Yeah, just precision, the tools are used to reverse the payload because payload is a binary. So the tools reverse the payload, but be careful about the keyboard layout because as it simulates a keyboard basically, we use a French keyboard, but by default payload or for the US keyboard, so it doesn't work. It types PowerShell, doesn't work very well. And if you have to reverse one of these, be careful about the layout. It could be a source of error prone.
And in this case, easy process, well played, finish, end of case. But in our case, the WID injector was hidden inside the mouse. And the component notification shows an Atmega Arduino-like controller, microcontroller, and a Wi-Fi module. we see here on the other side a Wi-Fi module with a shield. Okay, so we have to turn on all the things, so you put off the shield, and you found just under the ESP module microcontroller, and just aside a flash memory. Our goal is to find interesting data for analysis, so we can assume in this in this chip we can find data that could be interesting. So let's try to dump this flash memory. The basic process, we unsolder the chip to avoid any potential interference. On this kind of circuit, there is a little chance for interference, but if you are dealing with a circuit like routers, you can have problem to dump directly on the PCB. And you solder it back on the breakout board to access more easily on the to the pin. This is an SPI pin, so you connect on this pin, and you invoke the Holy Spirit of electronics, and we will see if it works. Our chip is supported by FlashROM. FlashROM is a kind of automated extraction tool where it supports a lot of flash memory, and basically it talks to the chip for you and extracts the data if you have the connection in the right way. So you use the best tool of forensics strings to test if your data is readable. Binwalk gave us no interesting result. Binwalk is a tool used to analyze dump of this kind of chip or exotic hardware, but in our case, no interesting data is given. Data seems readable. If the target chip was not readable, you can use a tool like DFRWS. With such tool, we end the datasheet, of course. You could talk to the chip with the supported command to read the data. Okay, so you see here, right here the command supported by the chip to read the data. Donc with the DFRWS, you can specify which data to send to the chip and check the returns, and you can script it to read all the data. This chip use SPFFS for SPI flash file system. Is used to manage file storage. At the moment, we are not able to fully understand it. We are working on it, but we are able to extract the Wi-Fi configuration with some interesting intel, 2 PowerShell payloads, and some intel about the attackers, giving us a great information if there is any OSINT fail on the attacker side. You can see our lovely incident creator here. So, some slide above learned that the attackers try to exfiltrate the content of a JPEG file through the serial port. And after analysis, 100 of chunk data with some grep kung fu and with a bite of luck, we were able to recover the stolen data, which is, in this case, the logo of our team. Now, if we speak about USB Ninja, if we keep the same process, somehow your forensics analysis leads you to forensics this device, but in this case, it could be more complicated to access to the hardware. Basic rules, tear down all the things again. So, this one is quite tricky. We need to bring out the big guns, and you need to open it to access to the internals, try to dump the microcontroller for data analysis, and do the same thing for the Bluetooth modules. And we are still going on this one, so stay tuned. So, as a few takeaways, as you will see from the keynote yesterday and of today, there is a lot to be done in the forensics field, and there is this kind of implant is no longer reserved to the national state-sponsored attackers. And the key to success is equipment and practice, practice, practice. You have to fail, you have to learn, you have to repeat. Thank you for your attention, and if you are interested or not, you can reach us to speak about the mouse. We can make some demo if you want. So, thank you.